So how do we find or generate the nth term rule for a quadratic sequence? Well, like all quadratics, the form, well, in this case, the form for a quadratic sequence is in the form of the nth term rule for a quadratic sequence is given by, the rule is Tn equals an squared plus bn plus c. Okay? So we'll work with this and hopefully it'll become clear. So let's find, now we're not given the nth term rule, now we're looking to find or create it, okay, or generate it. So let's find the nth term of the sequence 3, 10, 21, 36. Okay, here are the terms. This is the first difference, this is the second difference. Okay, so now we know that the second difference is 4. Okay, and we said at the end of the last video that the coefficient of the n squared value is equal to half the second difference. So the second difference is 4. So here's our coefficient here. The second difference is 4. So our a value then must be equal to a half times 4 is equal to 2. So our a value here, we're working towards generating the nth term rule for the quadratic. We now have our a value. Our a is equal to 2. So we're looking now for our b and our c. So how do we do that? Well, the best way to do that is to just pick the first term and the second term, t1 and t2, and just express those in terms of the b and c. Okay, so t1 is equal to an squared plus bn plus c from the form here, but we know what a is and we know what n is because it's 1. So if we go through with that, we'll see that t1 is equal to 2 plus b plus c. Okay, but from the sequence t1 is 3, so we let 3 equal this, all of this here, and we generate this equation 1 equals b plus c. Okay, we'll do the same for t equals to 2, so we know a is 2, n is 2, n is 2, and we'll get t2 equals 8 plus 2b plus c. But t2 is equal to 10, the second term is equal to 10, so we'll equate 10 to all of that, and we'll generate a second equation. 2 is equal to 2b plus c, and we'll solve equation 1 and equation 2 simultaneously, and change the sign and add and all of that. We will end up with b is equal to 1. If we let b equals 1, sub it back in there, we'll see that c is equal to 0. So our nth term rule for that quadratic sequence Tn is equal to 2n squared plus b is 1, n. 2n squared plus n, and there's no c. Now, just a quick note on graphing sequences. If we have a linear sequence, 1, 4, 7, 10, and 13, that should be. Sorry, no, not 13. Then the term 1 is 1, term 2 is 4, term 3 is 7, and so on. And if we were to plot t1, t2, t3 on the x-axis and the values on the y, if we were to plot t1 comma its value 1 as an ordered pair, t2 4, t3 7, and so on, we would get a straight line graph, and that proves that the sequence is linear by plotting each term as against t1, t2, t3, t4. A quadratic sequence looks like this, and if we take the ordered pairs of the first term and its value, the second term and its value, and we were to plot those, t1, t2, t4, we would get a curve, quadratic curve. And the quadratic curve, if we had more points, it actually takes either that, or it takes a shape of a parabola, either this way or that way. We'll meet that in another chapter. Okay, and then we will meet also exponential sequences as well. An exponential sequence looks like the nth term rule is a number to the power of n. So for the first term it's 3 to the 1, second term is 3 to the 2, 3 to 3, 3 to 4, 3 to the 5, and so on, if that's the nth term rule that we're given for this exponential sequence. And a plot that gives a graph with very fast growth. In other words, it shoots up all of a sudden. Its value increases dramatically very quickly. And let's just take a moment now just to look at an application of graphing sequences. And you can look at page 374, 375 if you're in junior cycle in your textbook for good examples. Anyway, a taxi company has a fixed charge of €4 and €2 per kilometre travelled. So create the nth term rule for this fare structure. Okay, well, the cost or the amount for the given kilometres travelled must be equal to two times the distance travelled, which in this case is kilometres, plus the €4 charge before you even pull off. Okay, so the cost is 2 times however many kilometres you travelled plus the 4 rate. So if we were to generate the sequence for this, if we let n first term, second term, third, fourth, fifth, or kilometre, 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 then the term rule would tell us that the term values, if I go 1 kilometre, I charge 6, 2 I'm charged 8, 3 10, 4 12, and 5 14. And this time, if I were to plot my n values along the x-axis and my tn values along the y, then just bear with me now. Sorry, these should actually be written the other way around. It should be n t1, n in the x, t1 in the y, and n t2, and so on. But just the idea is just to show you that you can generate a sequence to produce the fare structure all the way along for kilometres. So you can just plug in 20 kilometres there, and you can find that it'll cost you €36. Okay, and you can plot a graph from the sequence as well.